Okay, so we are back into logarithms with section 4.5, applying the properties of logarithms. So today we're going to focus on converting logarithms by either expanding them or condensing them, and that will be used to help us solve logarithmic equations in the next section. So our objectives are to use the properties of logarithms and use them to solve some problems. So logarithmic functions and exponential functions are inverses, as we have learned. So the properties of logarithms will follow directly from the properties of exponents. So back in chapter 2, we had done all the exponent properties. So logarithmic properties are kind of similar. So remember, logarithms are defined only for positive reals, and the base of a logarithm can only be a positive real other than 1. So if we remember back to the product property with exponents, let's see if I can get this to, there we go. No, I think my pen's dead. All right, hang on 1 second. All right, so if we take a look at, we have 3 properties here. We have the product property, the quotient property, and the power property. And they're very similar to what we had done with exponents. So if you look at the first property here, the product property, basically we're saying that the log of base b, and then you have the u times v here, is the same thing as log base b of u plus log base b of v. So if you remember, like when we did, let's say, x to the third times x to the fourth, you were kind of like adding those exponents. It's kind of similar to that. So you're sort of adding the 2 logs to get that combination. Quotient property. So when you have a fraction here, or a quotient, you can basically separate it by using the subtraction. So just like what we did back with exponents, if I had, let's say, x to the 7th over x to the 3rd, I would subtract my exponents and get x to the 4th. Same idea here, you can expand it using subtraction. And then over here we have log of, I don't know what this thing is here. If I have log here with a power, I can take that exponent from the power and bring it out to the front and make it a coefficient. All right, so first thing we're going to do is expand the expressions. So this first expression here, we see that we have a 7 times b. So when we want to expand that, we're going to use that first property that we saw up here, and we're going to use that plus sign. So it's going to be log base 2 7 plus log base 2 b. Okay, so then let's take a look at number 2. So again, for number 2, we have this entire piece here, which is actually 3 things being multiplied together. So the first thing we want to do is separate each of these into separate log terms. So we have log base 7 with the 2 plus log base 7a cubed plus log base 7b to the 4th. Now each of those exponents then is going to get bumped out to the front. So this little 3 here is going to come out to the front. This little 4 is going to come out to the front. So our final answer would be log base 7 2 plus 3 times log base 7a plus 4 times log base 7b. So that would be the expanded expression for each of those. So now let's go down to number 3. Now number 3 is an example of a quotient. So if we want to expand this one, we're just going to expand it by taking the log base 8 of the numerator and subtracting log base 8 of the denominator. And that's how we would expand that one. Now you could possibly see this written as 1 minus log base 8 3 as well, because if you remember from an earlier lesson, if you have a base 8 or any base, whatever it is, and this number here the same, that cancels out and just turns to 1. So just realize that both of those are the same. Okay, so for number 4, now you might be like, well, what am I going to do? This is just one number here, 49. So sometimes if you needed to expand this for a certain reason, maybe you want to get that, some other number there, what could you change it to? You could change it to 2 numbers multiplied together and then break it up. Or you might notice that 7 times 7 is 49, and you can rewrite it that way. And then once you do that, you can move that number out front. So 2, sorry, my pen's kind of wonky here. 2 times log base 6, 7. All right, so now we're going to get into some that are just a little bit more detailed. So if we take a look at this first one, the first thing we notice is that we have the quotient there, so we want to separate it that way. So we have log of the square root of x minus log times y. Now, you can't really leave, if you're expanding, you don't want to leave a radical in there. That's actually the more simplified answer. So you would want to change that. Now, I don't know if you remember this, but back from, I think it was chapter 3, you should remember that square root of something is the same thing as raising it to the 1/2 power. So you would technically have that there. And then, of course, to expand it a little bit further, that 1/2 can come out to the front, making it 1/2 times log x minus log y, and that would be the fully expanded answer. Okay, so for number 6, again, we have this whole big thing here. So we actually have 3 pieces in here. We have the 81, the x squared, and the y. So the first thing I'm going to do is separate each of those terms with their own log. So we have log base 9 81 plus log base 9 x squared plus log base 9y. So that's the first thing you want to do is separate it. Either all the things that are being multiplied together get their own term with the pluses, or the things being divided like in number 5 with the subtraction. So now at this point, you know that you can take this little, you can take this little 2 here. And bring it out to the front. And then this 81, we could rewrite. So I'm going to make this log base 9 squared. So now I can take this 2 and bring it out front. So I'll have 2 log base 9, which actually will cancel. So that's just 2 plus 2 log base 9x plus log base 9y. And again, if you still have the log base 9 there, it's not a big deal, but just for multiple choice purposes, sometimes that is canceled out or reduced. It's sort of like you would never leave a fraction as 2/2. You would simplify to 1 or something like that. Okay, and then looking at numbers 7 and 8. Now this one here for number 7 is a quotient. So the first thing we're going to do is separate the numerator and the denominator. So I have ln of 5m to the 4th minus ln of 3n squared. Now I'm going to put those separate like that because they're still going to be broken down some more. Now, basically what it boils down to is any of the terms that were in the numerator are going to be separated with plus sign. So it's going to be ln 5, which is positive, plus ln m to the 4th, which is positive. And then the ones on the bottom are all going to be subtracted. So essentially they're all going to be minus. So minus ln 3 minus ln n squared. And then when you go from, when you go from there, you're going to have to move those exponents out to the front. So we have this one here. And this one here. So we have ln 5 plus 4 times ln m minus ln 3 minus 2 times ln n. And that's your fully expanded problem. Okay, now this one here, because we have a radical, we want to rewrite it as, if you remember, the power goes on the top and the radical goes on the bottom. So this is actually x to the 5/3 power. Then, of course, that is going to go out to the front. So it's going to be 5/3 times log x. Okay, so that is our expanding. So I'm actually going to just do one more. We'll go on to condensing tomorrow. We're just going to focus on the expanding right now. Change of base formula I already went over with you in a previous lesson, so I'm not actually going to worry about that right now. So let's just go all the way to the end. There's a challenging expand one. And then we're going to stop there. Okay, so we have this numerator here over this denominator. So remember what I said on that earlier problem? Basically, everything in the numerator is positive. So log base 2x squared plus log base 2 radical y, and then minus log base 2 minus log base 2z. So if you do it like that, it just helps you avoid having to do the parentheses. So now we know that this first one here, the 2, is going to go over to the front. So it's going to be 2 times log base 2x. Then this next one is really log base 2y to the 1/2 power. And then we have this one here, and then this one here. So the last thing we have to do is move this 1/2 out to the front as well. So my final answer would be 2 log base 2x plus 1/2 log base 2y minus log base 2, which could be canceled out and just written as a 1, minus log base 2c. Okay. And that's it. And I'm going to actually just go back over change of base real quick from the calculator, which I've already explained in a previous lesson, but we'll stop there and then we'll finish the second half of the lesson on Wednesday. So just going back really quickly to change of base. This is really just for people with the older versions of the calculator. So if you do have one of those older versions of the calculator and you cannot type in a log with a base, you basically have to just use your common log with the bigger number and then divide it by the common log of the smaller number. So if you were going to do this one on your calculator here and you don't have a newer calculator where you can type that right in, you're just going to do log 7 divided by log 2 on your calculator, and that's it. So that's just a little refresher for you. And that's it for today. So you're just going to work on doing the expansions. I know it can be a little tricky. Tomorrow we'll go over the condensing, which is just the opposite. And then Thursday we'll be solving equations, which we have to use some of that to do that. And that will be it for logarithms. You guys will be excited about that ending, I'm sure. All right, and that's it. I hope you guys enjoy the rest of your day. Thanks.